Hey everybody. Today we're going to work through, you can see at the top of the screen, the concept of a scatter plot and then us discussing correlation. So what we're going to look at then is the idea of taking sets of data and graphing it in order to get a picture idea of what it represents. And then the correlation part is us examining a potential relationship with that set of data. So I want you to take a look on your screen right now, and you'll see that what we have is a particular situation. A study was conducted with the relationship between the age at which a child first speaks and their level of intelligence as teenagers. So I have given you a table that shows the ages of some teenagers when they first spoke and the results on an aptitude test. So what I want you to do is take a look at that table, and then I'd like us to go through and follow the instruction directly below the table, which is I want you to plot the points that represent each teenager's results from the table. So let's take a look at that table, and then let's take a look at the grid provided. You'll notice that the age when first spoke is in X months. And you'll notice that there is our X-axis that lines up. We then have the aptitude test results, which is our Y value, and that lines up with our vertical. So what I would like you to do is to go ahead and plot the points that represent each teenager's results from the table. So what we're going to do is we're going to go ahead and we're going to plot that data. Okay, I'm just going to blow up that grid a little bit. What you see on your screen now is just everything blown up. We don't have all the wording with the problem, but now we've got a bigger grid to be able to do our work with and analyze. So I think that we should be comfortable to be able to go through and plot all of those points where we're talking about the X number of months versus Y as our aptitude test. So what I'm going to ask you to do, go ahead and plot your first two pieces of data. Like that is, plot a 14-month-old and then their aptitude test, plot a 27-month-old and then their aptitude test. And then what we'll do is we'll come back and we'll double check and see how things are going, and then we should be good to be able to finish off this graph. Okay, I want you to go ahead and try to plot those first two pieces. Pause the video now. Okay, we're back. So for us to be able to plot that data, what we're really looking to do is to plot that first point at 1496. So I would go along my x-axis up to a point that showed 14. There I am. You can see the orange marking down on the axis. Then I would have to go up to where 96 would be on my vertical axis. And I want to try to plot where those two values would match best. And I think that that's a pretty solid estimate at that orange circle, that orange dot. Okay, there would be me going ahead and plotting that first piece of data. Now I want to get rid of my markings on my axes, so I'm going to get rid of, and I think I should be good to actually get rid of that circle outline on my point. In fact, I don't think I have to now label or connect any of those points. I should be good to just be able to plot the information. So if I take a look at the second one now, for a month of 27, I would have to go up to approximately where 69 would be, which is not very high, and there's a wrong. If I have to try to get right on that grid line, I think I'd be about there. So I'm now going to plot that point that would exist there. Okay, I'm just going to delete those little markings because I'm never going to put those on my graph. And I think that should line up pretty good for our first two data points. Okay, that should give you a little confirmation as to how to go through and plot that data if you needed it. So let's pause the video now and let's complete graphing all of that data. Okay, pause it now. Okay, we're back. So you take a peek And that should be what we have for our completed set of data. And I want you to take a moment and just see, how does your graph match up with mine? We're doing the best we can to estimate the location of each of those points and to try to be as accurate as we can be. What you now have with respect to all of those orange points on each of those axes is what is referred to as a scatter plot. That is, all you did was take a particular relationship and you put that in the form of a picture by putting all of that data in its location. Okay, hopefully we match up with that and we are good. What I want to do now is I want to spend a good chunk of time talking about the second concept for today. That is, how do we take a scatter plot and analyze the relationship? It's time for us to start looking at correlation. So, as you work your way down your handout and on that sheet, what I want to talk about now is the concept of correlation. And you'll notice I put a little definition up at the top of the screen. For us to talk about correlation, we're just talking about a relationship or a connection between two or more things. One of the things that we can talk about with respect to correlation is the idea of direction. Okay? Direction is not the only thing that allows us to talk about that relationship, but it's one of the key things that we would talk about. Now, what I'd like us to do is I'd like us to take a look at what's going to be like 3 headings. Okay, you see a heading right now of a positive direction or a negative direction or something that's referred to as no correlation. And what I want to do is I want to give you an idea of what we'll be talking about for each. I will expect that you will be able to comment on the direction of data. So if I gave you a scatter plot, could you tell me what the direction was if that had a correlation? So let me give you an example. What we're talking about when we talk about direction, we're talking about the direction that the data moves. And I say moves with like quotation marks on it because the data doesn't really move. But what we're talking about is as we scan our graph from left to right, what happens to the location of the data? So if we're talking about positive direction, then that means that your data would be moving up as we move left to right. So you'll notice that that arrow that I just drew is an arrow that rises as I move left to right. Okay, I want to get rid of the arrow component to it now because it's not really moving. So if my data was to lay in that position that you see in purple, we would call that a positive. Now, I also want to make sure I don't put an idea in your mind like it has to be a line. Well, this would be positive, or this would be positive. And again, I want to get rid of the arrows now after we've talked about them, because now we can just start to see data lying in certain positions. Our eyes are moving left to right. Same thing with respect to negative. Negative would be talking about falling to the right. Maybe that's a line. Maybe that's a curve. In all 3 of those cases, that is falling as I move left to right. Now, I also don't want to put an idea in your mind that it has to be a solid line, because I think what we saw from our previous graph, scatter plots are a series of points. So now what I want to do is I want to put on just a quick example of what a positive direction could look like with respect to data. Maybe it's something that follows this trend. And it's weird. I just wanted to put like a wavy thing in there, some real curvature. But just notice, it's a series of points that all would rise. Now, you could make an argument that if you connected those things line up pretty well. So what we would also be talking about if we said negative is just a series of points that happen to all go in a negative direction. You take a look at that negative example of data points, and you'll notice those would not connect to a line or a curve. But all of those points tend to be falling as we move to the right. Okay, I think that that's going to really help us when we talk about what no correlation is. I'm going to put on a set of axes just to help give us some perspective. But I want you to imagine that my blue set of axes was my X and my Y axis. Then what we would be talking about with no correlation would be something along the lines of, I seem to have some points that are all over the place. Like maybe even to the point where we would say, I don't see a pattern to it. It doesn't seem to be following a certain trend, a certain direction. Okay, I hope that helps to get the idea of direction down. I will be asking you to comment on the direction of data, and we need to make sure that we are good to explain whether it's positive, negative, or no correlation. Okay, let's jump into another thing we have to examine when we talk about correlation. What you also see now up at the top of your screen is us talking about the concept of form. And what I mean by that then is, what is our connected shape? That is, do we see a shape to it? And if we do, what is it? So when we talk about a linear form, what we're talking about is exactly what that word looks like, line. That is, does my data line up? Maybe in a positive direction, line up. Maybe in a negative direction, line up. That's going to be a difficult one we would talk about a little bit later. But maybe in a horizontal way, no direction, those sorts of things. Versus, take a look at your next heading. Your next heading is non-linear, non-line. So now what we would be talking about is maybe you have a curve. Bending up, bending down. Maybe it's an arc, something like that. Our data takes a form, but it's not straight. So it is not a line. I'm going to expect you to comment on a scatter plot on a set of data based on its form. Is it linear or not? Okay, let's take a look at another criteria. You see up at the top, what we're talking about now is the concept of strength. And so what we mean by strength is how well does it fit that form. Okay, I want to give you a couple of examples to make sure that we're good. To do that, I'm going to put on my set of axes again, only because I want to make sure that we're not confusing any of these shapes based on a set of data that just look like they're floating somewhere. If I was to go through and plot a set of data, and when I plotted that data, and I'm just going to get rid of that point. It's a little bit too big for what I'm looking for right now. But I was to go through and plot that data. And I got to a point where that data lined up so well, like it was so in line that I was able to take a straight edge and draw a line that passed through that data. Notice, it's not a curve. That is a line. It is perfectly straight. Listen to my language. It is perfectly straight. Then we would call that a perfect strength. Now, it doesn't have to be a line. So if I went through and I did the same thing with my set of axes, and maybe when I went through and I plotted all of my data, And then I was able to connect it with a perfect curve. Perfect. Then there's another example of perfect strength. Okay, I think we might have a decent idea of what perfect looks like, but not a great one. I think if we talk about what strong might look like, we might be able to see the difference. So, same thing. I'm going to put on a quick set of axes. And if I was to talk about strong data now, then maybe what we're talking about is something like this. I want you to take a look at all those data points that I just plotted. And what you might notice is I cannot connect those with a line. Like if I was going to take my straight edge again and try to go through those, I notice, yeah, I pass through a bunch of the points, but I don't hit them all. They don't all line up. Or they don't all line up perfectly for a curve. If I was to try to connect those, then I would end up getting a zigzag. But look how tight all that data is. It doesn't perfectly line up, but it is pretty condensed. Like it is pretty compact. So one of the tools that I can use, if I just go and erase that data point or that line, is if I went to go through and draw a line that follows the direction. So in this case, I hope we can see all of our data looks like it's rising pretty well. So it's positive. And I just draw a line directly below that data that follows its pattern. And then I do the same thing on the top. And I try to hit as much data on top. Then those two red lines that I just drew are really close together. And the closer they are together, they describe how strong that data lines up. Okay, does it line up perfectly? No. But is it pretty compact? Yes. So we would use that description to say it's a strong relationship. Like it's not perfect, but it's really close. It's strong. Okay, one last counterexample so we can kind of put these two ideas together. If I made it a curve again, and that bottom line got really out of whack. So if I made it a curve again, if I took that data, and maybe just so you don't always think it has to curve down, and now I just made that data curve up. Well, we can clearly see that those data points do not line up. So it's not linear. But it does take a curve, so it's nonlinear. If I was to do the same thing with the red, but now draw a curve that fits on the inside of all that data, and then a curve that fits on the outside of that data, can we see again how close together all that data does line up? Yes, it is not perfect. It's not a perfect curve, but that data really does take that form. That we could use that description of saying that it was strong. Okay, when we get to the last three, there really is judgment. Like whether something is strong, whether it's moderate, whether it's weak, this is where it tends to be judgment calls. Like I think for a lot of us, we can identify perfect. And maybe we can identify strong, maybe. But then when we start to break into, well, then what defines moderate? Well, really what we're talking about is for each of those instances, do my red lines that contain the data spread out farther? If I was just to create a scatter plot that matched for us a comparison to strong, then maybe I make those data points increase again. And maybe if I was just to get rid of maybe those two, then maybe that helps us a little bit. That what you might see is if I was to draw my line now that goes on top of the data, then I would be able to go through and say there's roughly on top of the data, there's roughly below the data. And you can notice that now my lines are getting farther apart, which means their strength is becoming less. So much so that if we worked our way over to weak on in the end, weak strength might end up being something where we're like, okay, we can clearly see the trend in the data. If I then went through to try to draw on my lines to help determine strength, they're even farther apart for my data. And so based on comparison, we should be able to see within those last three, the way something strong would compare to moderate, would compare to weak. Okay, so those happen to be the three things that I'm going to ask you to be able to describe with relationships when we look at scatter plots with respect to correlation. Okay, is there a direction to the data? Is it rising to the right, falling to the right, or none? Does the data take a shape to it? That is it linear? Is it nonlinear? What's its form? And then lastly, what's the strength of that? So if it is linear, how strong does that data line up? If it's nonlinear, how well does it match up with a curve? Those are going to be what you're going to be required to talk about. Okay, I gave you some sets of data and some very, very crude drawings of those scatter plots. I want to go through a few more examples just to give you a better idea of what some of these relationships may look like. So, what you see on your screen right now would be an example of a certain type of correlation. So, if you look on the graph on the left, you'll notice that would be an example of what we would call a perfect positive correlation. Okay, let's look at the green part first, positive. I hope we're good that when we take a look at that data, we notice that that data is rising to the right. Why would I call it perfect? Because from a strength standpoint, if we were to try to go through and see, does that data line up? I could draw a line that would go, and I'm going to do my best here to be as accurate as possible, but I could draw a line that goes through every single one of those data points. So it would be described as perfect. Look on the right case, and I don't think you even need me to put on the shape. We should be good that that is a negative correlation because my data is falling to the right, and it would be perfect because all of those data points line up. Okay, we're going to keep it going with a few more examples. Take a look at the 4 pictures I put on now. And again, this is what's going to help me to be able to go through and tell the difference between something being perfect versus strong. So you see the same 2 graphs that we just discussed on the top part of the screen. But now you take a look at the 2 graphs on the bottom. You'll notice that the bottom would be described as strong. And if I was to go back and do what we discussed earlier, we notice that on the bottom left graph, my strong positive correlation, my data does not line up in either a line or a curve. But if I was to draw a line on the top of all that data and a line that passes through the bottom end of all that data, we would see those lines are really close together. So that data all kind of fits in a tight set of lines, which means it almost lines up, like it's really condensed. And same thing for the bottom right graph. If you were to go through and put on those lines showing the range of that data, we'll find that those two lines are pretty close together. Now you start to take a look at two other graphs, and you can start to see where we do have a positive direction. So if you take a look at the positive component, we can see all of our data is moving up versus the negative direction, our data is moving down. So we can see the trend in that data in terms of direction. However, if we were to talk about strength, and I'm just going to get rid of those orange arrows now, but if we were going to talk about strength, you can really see that as we're talking about that data, to get on the high side of that data, like I am way out here. And then on the bottom side of that data, I am way down here, that those lines really start to become farther and farther apart. So we could describe that as having a weak strength. It's not very strong at all. Yes, the data is rising, so it's positive, but it really isn't all focused. It's not condensed at all. It's pretty spaced out. Okay, you can look at the graph on the right, but I think we see the same thing. Okay, what I want to do is I want to go to two graphs now where we might actually have difficulty explaining one of them. So let's look at the last two. What you see on the left side of your screen would be something that would be called no correlation. And I imagine that for a lot of us, we would look at that and we would go like, well, duh, there's no correlation to that. Like, there's no pattern. You know, your dots just seem like they're everywhere. There's nothing that seems to be rising, nothing that seems to be falling. It doesn't seem to be a curve. Doesn't seem to be a line. If it was a line or a curve, then that data would be so spaced out that we would say there was no strength. Okay, there is no pattern to that thing at all, no correlation. But it's the graph on the right that I think we might have some people who would be very reluctant to use the term no correlation and would actually start to talk about that data in an incorrect way. Let's take a look at the graph on the right. That I would have a bunch of people that would describe that as having a correlation because you can see a pattern to the data. And I want to make one thing clear, and it's one thing that maybe we have to clarify from earlier, now that we have some more vocabulary with us. What we're talking about is the relationship between things. And so if I look on my axes, I'm talking about the relationship between X and Y, whatever those things are. What you may notice then is there's really no relationship between X and Y. Okay, take a look at my data. As my X increases, and so I'm just going to put on this arrow here to show that we're moving like this. My X values are going from being very small to bigger in the direction of the arrow. As my X values increase, I notice that my Y values seem to float about the same thing. You know, a little bit higher, a little bit lower, but within that range, and it's a pretty close range. So what I see then is, as my X increases, my Y hardly changes. That's what makes me think, based on the pattern, that my Y does not depend on X. My Y is going to be what it is going to be, regardless of what's happening with my X values. And that's why it would lead us to no correlation, or almost even a statement that says there's no relationship between X and Y based on that data. So I want to make sure that what we're always looking at when we examine this data is the relationship between one thing we're measuring and the other. Let's take a look back at an old graph now. So let's take a peek at that slide we looked at earlier, comparing perfect versus strong. And maybe since we already talked about the strong part, let's look at the negative. So I want you to look at the bottom right, and we'll look at the strong negative correlation. The reason why we call that a negative correlation is because of that relationship between one variable and the next. And so just for the ease of discussion, let's call it y and x again. But you'll notice that as I move left to right, I'm talking about as my x increases. That really the word negative is what finishes off the description of my y values. So if I go back to that blue arrow again, as my x increases, I find that my data goes down. As my x increases, my data falls. And you can see that with that trend line. As I move left to right, I say that formally, as x increases, my data goes downward, falls to the right. Really what I'm talking about then is my y values are falling, therefore negative relationship. We're always talking about the direction of our relationship with a statement of as x increases. And so maybe that's why we can see that horizontal relationship as really having no relationship. Okay, I want to go back to the very first problem we did today, just to kind of sum everything up. Okay, so here is that scatter plot that we produced at the very beginning, talking about the age when someone first spoke and then what their aptitude tests were as a teenager. If we had to start to try to describe that data now, well, you notice some of that data is pretty spaced out. I think at the very least we can see from a form standpoint that that is not linear. Maybe it's nonlinear, I don't know. At the very least, we can all say it is not perfect and probably not strong. Here's where I want to talk about one other concept. When we start to examine the strength of data, then we want to use those lines, those ideas that tell us how condensed is our data. Well, I think I could make the argument based on that data that that data seems to be falling to the right. Well, if I drew one line that way on the top end and one line, on the bottom end and one line on the top end, then I could kind of look at my data as fitting in that, which really does lead me towards a negative direction. But I would really want to say that that was not very strong at all. Like I would probably call that weak, maybe even very weak in terms of strength. However, that would be described as weak if I had to include every piece of data. That is, if I felt like every piece of data was just as important as every other one. And perhaps if I was to exclude a piece of data, that I might be able to look at that right now and say, well, maybe I've got these two pieces of data on the bottom that don't really fit the pattern. And if I was to look at the lower side of my data as there, then all of a sudden my lines start to become closer. If I was to try to be as exact as possible on the high end, then maybe there's my top. I might actually say that that's a moderate or a strong strength now in the negative direction. It was just these two bottom pieces of information that kind of skewed my pattern. Well, if I was to view that information now, then I may describe something in a certain way. I could say that I think these two pieces of data are what would be referred to as outliers. That is, that would be data that doesn't fit the pattern, so much so that I'm going to rule it out as almost an anomaly. I can't go and rule out most of the data. No, but if there's one or two pieces of data, then maybe I say they don't fit the pattern. I'm going to exclude it and I'm going to analyze the rest. If I was to view that data, I could describe that then as maybe having a linear relationship. Like, it does line up pretty well. It's not going to be very strong, it's not perfect. Maybe it's strong to moderate in terms of strength. But I could definitely say that it is negative in direction. And I may say all of those things with two outliers. And that could be a way that I examine the data we looked at the very beginning. What would that allow me to state with regards to that relationship? I could draw a conclusion, so therefore, as my X increases. Now, my X in this case was the age when people first spoke. So as the age when a person first speaks increases, and what that really means is the person is older and older and older, then what happens? Well, it's a negative relationship with my Y value. My Y value being their aptitude. So as the age when a person first speaks increases, their scores on the aptitude test decreases. And that could be a conclusion that data leads me towards. Okay, I'm hoping for today we got a little bit of review of what a scatter plot was. We're fine on plotting points. You picked up some vocabulary with respect to what you see on the screen, how to make a concluding statement in blue. And you can look at, in purple, the three things we would have to comment on with respect to correlation. Okay, your job. Jump in, get some practice, and get comfortable with all that new vocabulary. Okay, best of luck.